All of the problems we saw in the previous section could be solved in one step. We're going to start taking a look at what are called two-step equations, starting off using the model, and then we'll see if we can do it without the model. Using the model, we're going to take a look at solving problems now like 2x minus 3 equals negative 5. So if I think about my model, 2x means I've got two positive x strips hanging out with 3 negative tiles. On the right side, there's 5 negative tiles. Now, we've got kind of two options that we can do in order to solve this. We know we can get rid of the 3 negative tiles by putting 3 positive tiles on. And we know we can separate the 2 positive tiles into 2 groups. So which one do we do first? Well, if we tried to split into 2 groups, we would have to make the 2 groups equal. And there's no way to split up the negative 3 into 2 groups without breaking one of them in half. So instead, what we're going to do is we're going to take care of the individual tiles first, taking care of the adding and subtracting. So we'll put 3 positive tiles on both sides first. When we do that, we end up with 0 pairs on both sides, really. And so what we're left with is going to be the 2 positive strips and the 2 negative strips. Now we're ready to break into 2 individual groups that are exactly identical on both sides. I can see that each one of those positive x strips is the equivalent of 1 negative strip. Looking at what we just did on the equation itself, we said if we balance on the equal sign, we get rid of those 3 negatives with 3 positives, which will give us 0 pairs, leaving just the 2 x's that are balancing with negative 5 plus 3 is negative 2. Then we can divide. Since we have 2 x's, we'll divide them into 2 groups. And that leaves just a single x is equal to negative 1. Let's look at the model on one more problem. Let's try 5x minus 2 equals 8. So if we balance on the equal sign, we've got 5 x's. 1, 2, 3, 4, 5 x's hanging out with 2 negatives. And that balances with 8 positives. Again, as we try and solve this, it wouldn't make sense to split up into 5 groups first because we've got these 2 negatives hanging out that can't be split into 5 groups. So we get rid of those 2 negatives with 2 positives, doing the same thing on the other side. That creates some 0 pairs. And so what we're left with is, on one side, the 5x strips. And on the other side, looks like there's, what, 10? 3, 4, 5, 6, 7, 8, 9, 10. And now we're ready to split up into 5 even groups because we have 5 x's. And if we split into 5 groups on the other side, we see each x strip balances with 2 positives. Visually, what we did, I'll put it off to the side here, 5x minus 2 equals 8. If we balance on that equal sign, we see those 5 x's hanging out with 2 negatives. We get rid of those 2 negatives with 2 positives, creating 0 pairs. So those 5 x's balance with 10. To split up that 5 from the x, since it's multiplied, since we've got 5 x's, we divide into 5 groups, division being the opposite of multiplication. Always doing the same thing to both sides. 10 divided by 5 is 2. And now we know how many chips are in each x strip. One thing you might notice as we're solving, if you remember GEMDAS, when we were simplifying, where we knew all the values, we went down GEMDAS, doing the grouping, exponents, multiplying, dividing, then adding and subtracting. When we're solving, we start at the bottom and work to the top when we're solving. So in other words, we'll do any adding or subtracting first and multiplication and division second. In future classes, you'll do exponents last and then grouping symbols even after that. But for this class, we're going to keep on the bottom 2 steps.